Okay, so we will learn Venturimeter. Okay, what is Venturimeter? It is a device used to measure the flow speed of incompressible fluid. Uh, that's the definition. So it measures what? It measures the flow speed of incompressible fluid. Okay, so this is the schematic diagram of this Venturimeter. You can notice here one opening is there and here exit opening is there. Okay, so almost the area of cross section of this end and this end is same only, but if you notice here the area of cross section here is quite smaller. Okay, and here a U-tube kind of a tube is shape is connected. Here some liquid is kept, so it is material under construction. It can be of mercury or any other fluid is kept. Okay, what actually happens is whenever this motion whenever this particular liquid moves, so this particular liquid, so it takes some height or a rise or fall of liquid takes place, so indicating that a variation of pressure. Okay, now look at this particular point here. A1 is the area of cross section at this point, V1 is the velocity of the fluid entering at this point, and I have taken here rho 1. Need not to take rho 1 also. If we take rho also, it's okay. I will take it as rho only. And here at this point area of cross section is A2. This particular area of cross section is taken as A2 and velocity of fluid is taken as V2, and I have taken rho 2. No need to take rho 2. You can take rho also, no problem, because same liquid is entering. So here the density of the fluid is rho. Okay, so these are the notations that we have assumed. Now, so what actually the definition of Venturimeter says? It says that it is a device used to measure the flow speed of incompressible fluid. So now let's derive the expression for this flow speed of incompressible fluid. So to do so, first we will take this equation of continuity. We know from equation of continuity what it says: A1 into V1 is equal to A2 into V2, right? So from this equation what happens? V2 is equal to A1 by A2 into V1. So similarly, from the same equation we can write the expression for V1. So V1 is equal to A2 by A1 into V2. Okay, so we have taken the equation of V2 and V1 from this equation of continuity. Now apply the Bernoulli's equation. So what Bernoulli's equation says? Bernoulli's equation says pressure and kinetic energy per unit volume and potential energy per unit volume is equal to constant, right? So that means fluid entering entire value and fluid exiting entire value should be same only. So now let's equate this equation. For this particular region, what is pressure energy? Let's take it as P1 plus half rho density same only, V1 square entry fluid's velocity V1 square plus rho GH, okay, is equal to P2 plus half rho V2 square plus rho GH. You can notice the height of this particular thing remains same. So H and H. So magnitude of rho GH and rho GH, if we take here, it get cancels each other. Okay, so now we are left with equation P1 plus half rho V1 square and P2 plus half rho V2 square. Now P1, take P to this side, P1 minus P2 is equal to half. So rho V1 square is taken on that side, half rho into V2 square minus V1 square. Okay, so P1 minus P2, this difference comes out to be rho GH. Okay, so you should notice one thing here. P1 minus P2 is rho GH, but I have taken this rho as rho M. Rho M is the density of the material under construction. So means what is there in this U-tube, that's density is taken as rho M. But here you find one more rho, that rho is the density of this fluid. So you should note this thing. So rho M GH is equal to half rho into A1 square, so V2 square value, substitute this value. So A1 by A2 into V1 is there, A1 square by A2 square into V1 square. So minus V1 square, this equation. So no need to substitute these things, just simply put V1 square only. Now same equation, so half rho, so V1 square is common, take out. Now left with A1 square by A2 square minus 1. Okay, now next, so rho GH, okay, is there, V1 square is there. What we want actually, we want flow speed of the incompressible fluid. So V1 square, so at this particular point, what is V1? Okay, so V1 square we want, put V1 square aside and take 2 this side, 2 rho GH, 2 rho M GH divided by rho into a1 square by a2 square minus 1 comes under the denominator. But instead of writing what I wrote, whole to the power of minus 1. Okay. Then what happens? So v1 square is there. We want v1. So v1 is equal to under root of 2 rho gh by rho. Again under root of a1 square by a2 square minus 1 whole to the power of minus 1 by 2 should come like this. But I have taken completely rho only. But if you solve this thing, so you will get a2 square by a1 square minus a2 square. So there ends. This is the velocity of the speed of the incompressible fluid.